Alright, in this video we're going to go over numbers 7 through 12 on factor number 6, which is working with that perfect squares pattern. For this one, it looks a lot more complicated than it actually is. We're really not doing anything that you don't already know. There are just a couple patterns and times that we need to identify when we want to use them. And then I forgot to show you how we would write our final answers, and so that's what made this one so difficult. So I apologize in advance. You can watch this video. We won't use a whole lot of these formatted answers for this standard. The next standard, you might have to use the answers, but you would have some form of technology that you'd be able to use to help you find them. So finding them by hand, we're not going to do a whole lot. So you can watch these videos. There's potential that something like this, especially something like this with fractions over here, might be something that would be in the exemplary level. So if you're curious or you want to try the exemplary level, I would encourage you to watch this video. Otherwise, watch it for fun or close it and have a good weekend. Alright, number 7. We're going to start with this one here. If we're going to factor and solve, usually we want to use the zero product property. So we're going to set this equal to 0. Normally I might move this 7r squared to the other side because it's less work, except that I don't want this to be negative if it doesn't have to be. So in order to avoid that, I'm going to move the 70r and the negative 175 to the other side. That's going to get us 7r squared minus 70r plus 175, and now that equals 0, so we know at the end we can use the zero product property. Alright, first row of factoring, we need to take out the greatest common factor. Take a quick look, see if you can figure out what it is. If you said 7, you're correct. We're going to remove a 7. That leaves us with r squared minus 10r plus 25, still equal to 0 because we haven't done anything to the other side. Alright, right here, this is one of our common perfect squares, so it might be a good one to start recognizing. Okay, so an r, a 10r, and a 25. Again, a plus or minus here will just change what it is in the end, if it's the sum of the perfect squares or the difference of the perfect squares. Okay, so here we have a difference, so we need 7 still on the outside. What times itself gets us to r squared? That's an r. Over here, 25, what times itself is going to get us 25? That's a 5. Because it's the difference, we're going to be subtracting. So we're going to write out the rest of it there. Now, good, this side's factored, this side's equal to 0. Now we need to solve. First I would divide by 7. That's going to be 0 divided by 7, still 0. At that point I have r minus 5 squared and then equals 0. From there, to get rid of the parentheses, I need to take the squared root to undo squaring. But the squared root of 0 is 0. So really I just have r minus 5 equals 0. And what minus 5 is going to equal 0? You're right. That means r equals 5. So this one only has one answer. Nice job. We're done. Let's go to number 8. Number 8. First rule of factoring, take out the greatest common factor if you can. In this one, we can take out a 2. So let's do it. 2, take that out. We have 9x squared plus 12x plus 4 equals 0. I see here a perfect square. If you don't believe me, let's check it out. I'm just going to write down this 2 to begin. Alright, what times itself would be 9x squared? Well, that's 3x. What times itself would be a 4? That's 2. Put a plus because there's a plus sign right here. Double check that middle term. 3x times 2 is 6x times 2 makes that 12x. Our pattern implies we're good. Don't forget your squared equals 0. Alright, now we have this side factored. This side's equal to 0. We're going to solve. Divide by 2 on this side to get rid of it. 0 divided by 2 is still 0. We have 3x plus 2 squared. To get rid of the squaring, we're going to take the squared root. 0, take the square root of 0. What times itself equals 0? Oh, that's still 0. So really, again, we just have 3x plus 2 equals 0. For solving for x, subtract 2 to the other side, divide by 3. So x is going to equal negative 2 divided by 3, because we just subtracted 2 and then divided by 3. So again, just one answer. Alright, number 9 and number 10 are the ones that the formatting looks really tricky on, and so I think in order to be able to explain that a little better, let's actually skip to number 11 and do this one first, and I think that will make a little bit more sense. Alright, usually when we're solving, we're going to try to set it all equal to 0 like we did up here. That was great, except this one is one time where we don't want to, because if you're good at seeing that there's a perfect square right here, we can actually use that to our advantage. So let's do it. Again, if you didn't See that there? It's going to make it a little bit more difficult. You can still factor some other ways. You just might run into a little bit more difficulty. So let's go ahead and try this and see if it works. If you really don't like this strategy, you can use our other strategies. So you could set it equal to 0 and then use our simple factoring, our simple trinomial factoring method. That would also work and eventually get you the right answer as well. But we're gonna go with this strategy this time since we're working on that perfect squares pattern. So what times itself is going to equal x squared? That's x. It's plus. It's the sum. What times itself equals 25? That's 5. Let's square it. Equals 81. Okay. So there we are. Now we're trying to solve for x. This side's already factored as well as most we can. This side is equal to 81. First thing we're going to have to do is take the squared root of this side. Now, because this isn't 0, we need to take the squared root of this side as well. So we're going to take the squared root, take the squared root. On this side, squared root and squaring cancel out. We have x plus 5. Great. This is the part we need to remember. Back to squared roots. So, squared root of 81. Alright, we usually think 9, but there's actually another one. What was that? Oh yeah. Negative 9 times negative 9 also equals 81. So we write it as plus or minus 9. So really there's two answers that can get us to an 81 when we multiply it by itself. So this is where this gets a little tricky. Just don't forget that plus or minus sign, because now on our next step we know we're going to have to subtract 5, but we need to do it twice. The first time we're using this plus 9. So a positive 9 minus 5. Alright, positive 5 or positive 9 minus 5. That means x is going to equal 4. But don't forget there's also this negative 9 down here too. So negative 9 minus 5, x is also going to equal negative 14. That's pretty crazy. Alright, so this one gets us two answers. We used this formatting here and it was okay because we had nice numbers. Okay, but number 9, let's go to this one now. We're going to do the same thing, but we don't have nice numbers because when we end up taking our squared root, it's not going to be a whole number answer. So we're going to just leave it with that squared root, which makes it look like a crazy answer, but it's really not any crazier than anything that we did down here. You'll see what I mean when we get to this one. So, number 9, this one's actually already been factored. This is already the perfect square. It's the sum of perfect squares because w plus 3 times itself, that means we're squaring it. Great. Okay, it's equal to 2. So now all we're doing on this one is solving. We need to take the squared root of both sides. Well, the squared root of 2 is not a nice number, and instead of putting it into my calculator and rounding it and then not having my answer be accurate, we're just going to leave it as a squared root of 2. So right now I have w plus 3 equals the square root of 2, but don't forget that can be positive or negative, so plus or minus. Since we're solving for w, we're going to subtract 3 from both sides, and so we're going to have w equals, you might be tempted to write it like this, plus or minus the square root of 2 minus 3. However, you won't really see it very frequently this way because it's hard to tell where the squared root ends, right? We know that it ends after the 2, but if you have sloppy handwriting or you're writing really quickly, you might draw this line too far, and then it looks like 2 minus 3 underneath that radical sign. So much more frequently, we're going to see it like this. W equals negative 3 plus or minus the square root of 2. And that would be our answer. So really, in this answer, we get 2 for 1. If we went and solved this in our calculator, we would put in minus 3 plus the square root of 2. That would be one answer, and minus 3 minus the square root of 2. That would be our second answer. It would give us two different values. Okay, but same idea that we did in number 11 when we had that 9. Here it was just a whole number. Here it's a squared root. And this is the part that I forgot to show you in class. That's what makes it so tricky. The rest of it is really just solving our equations, figuring out what form of factoring to use. So keep working with that orange sheet to make sure that you're figuring out which form of factoring you need to use at which time, and that will get you a long ways. Alright, let's finish out these other two. I apologize, this video is kind of long. Number 10, we're going to do the same thing. You might be tempted to set this equal to 0, but hang on, this is already a perfect square. It's the difference of perfect squares because we're subtracting. So x times itself is going to get us x squared minus 6 times itself is going to get us 36. We square it, it's equal to 11. We want to take the squared root to get rid of the squared root, but that means we have to do it on the other side. Square root of 11 is not nice. Let's just leave it as the square root of 11. So x minus 6 equals the square root of 11, but it could be positive or negative. We don't know. Now we have to add 6 to the other side. Our answer is going to be a 6 plus or minus the square root of 11. So really, again, two answers in one right there. All right, last one, number 12, just a hint. I like this idea of fractions, so this would be a really good one to study for, to see if you can find those patterns for something like the exemplary level on the test, using those fractions, but still using those same patterns. Just a hint for you. All right, so believe it or not, this is a perfect square right here. Don't believe me? Watch this. What times itself equals a squared? Well, a times a. You're correct. It is a plus. It's a sum, so we're going to be adding on this one. Now we need to figure out what times itself is going to equal 4 25ths. So we can break this down. Because remember, when we multiply fractions, I'm going to do it up here. If we had, say, the fraction AB, and I multiply it by the fraction AB, that's going to give me, oh, you can't see that. Oh, go back over here. All right, that's going to give me a squared over b squared, because b times b and a times a, those are going to give us squared. So really, if I can break this down into two separate parts and figure out the square of each of these, I can figure out what that's going to be. So looking at the top, what times itself is going to be 4? That's a 2. On the bottom, what times itself equals 25? Well, that's a 5. Let's double check that middle term just to make sure it still works. If I take 2/5 times a, well, that's 2/5, and I multiply that by 2. 2/5 times 2, that's 4/5. And there was an a on there, so 4/5 a. Our pattern still works. Don't forget that we have it squared right now. And that needs to equal 0. That's about 0. From here, we're going to solve. First, we take the square root to get rid of the parentheses. If we take the square root of 0 is 0. So I really have a plus 2/5 equals 0. What does a have to be so that when we add 2/5 we end up with 0? You're right. A equals negative 2/5. On this one, we only have one answer, and that would be it. All right, again, congratulations. You got out of doing 6 problems because I messed up once again. You're welcome. Have a great weekend.